Alrighty. Another lexo. This damn word. Lexicographically smallest equivalent string. Medium. You're given two strings of length S1 and S2 and a base string. We say that S1 of I and S2 of are equivalent characters. For example, if S1 is ABC and S2 is CDE, then A and C are equal, B and D are equal, and E and C are equal. Equivalent characters follow the usual rules of equivalence relationship. A character is equal to itself by symmetry. If A equals B, then B equals A. And by transitivity, A equals B and B equals C, then A equals C. For example, given the equivalence information, ABC equals CDE, ACD, and AAB are equivalent strings of the base string EED. So I think here, if you start with EED and you want to get to something that's equivalent to it, that is lexicographically smallest, then E becomes C and C becomes A. So the E's become A and the D, which is equivalent to B, becomes that. So that's AAB. Okay. Return the lexicographically smallest equivalent string or base string by using equivalence information from S1 and S2. Okay. So if string 1 is Parker and string 2 is Morris, and we're trying to find the lexicographically smallest equivalent of parser, then P becomes M, A is A, R is R, or R is S. R is better. S becomes R. R, S, and K are equivalent because of the K is equal to R here. So this R and this S becomes two Ks. E is equivalent to I, and E is better. And then R becomes K, so it's McKick. Okay. So seems to me like you probably want to have for each letter a link from the letter to the set of things that are equivalent to it, and then maybe find the earliest element of that set. Yeah. Okay. Sure. Let's go with that. So let's say for each letter, I associate each letter to a set. Maybe a set ID, because the sets themselves need to associate to an earliest element, and you can't hash sets. So if you have a certain set, you need maybe a ID associated with the set. Okay, so let's say set IDs is a list of, let's say set ID associates each element to an ID number. Let's say ID starts with 0, and then ID sets is going to be dictionary where I go from some ID to some sets. Maybe a default dictionary. Default dictionary of sets. And then for each, let's say for each letter I associate with an ID number. So ID letter ID, and I'll say it's -1 for each letter, and for each element, say n is equal to the length of index, length of the S1 for index in range n. I get the two letters, I'm going to say letter 1, letter 2 from my S1, S2. So for instance, if it's P and M, S1, S2 index. So if it's P and M, and there's two things that could be, or there's some cases could be, let's say that it starts with not being associated to any sets. So I'm going to start by let's say ID count. Let's say I'm going to use the current ID. If the letter ID of let1 is equal to -1, and the letter ID of let2 is also equal to -1, then I'm going to create a new set to have to contain both letters as equivalent. So I can say current ID is equal to ID count. Increment the ID count so that it doesn't get used again. Letter ID of letter 1 is equal to the current ID. And also letter ID of letter 2 is equal to current ID. The letters are currently being used as indices. So unless I want to make this into a dictionary, I probably want to just convert the letters into their integer equivalents. So let's say let's say S1 is actually S1 becomes the integer, the ordinal number of k minus ordinal of a for each k in S1. And then let's go ahead and just print out and make sure that's correct. I think that's right. So it should convert a to 0, and then p to 15, r to 17, k to 10. That seems right. Like that's the offset each letter is from 0, where 0 is a. And then for string 2, it's ordinal of k minus ordinal of letter a for every k in S2. Okay. So if the ID count is that, and the letter ID, so once I have an ID for the set that they are going to be linked to, I link that in this array. So letter ID of the letter 1. Letter 1 is the index here, or letter 2 is the the index in the other one is going to be equal to, I guess it's equal to the current ID, and letter ID of letter 2 is also equal to current ID. And then, so that's the case where they don't have some linkage already, where the ID has some set associated, where each letter has some prior set of equivalent letters is associated with. Now it could be that you're combining sets. So with one doesn't have something but the other one does. So let's say else if letter ID of let 1 is equal to -1. So because it's not both of them -1 unassociated, only letter 1 is unassociated, then that means the other one is associated with something, and I need to add this letter to the set that the other one is associated. Oh, I need to also create the sets, right? ID sets of this current ID, append, no, add, sets add, arrays append, add letter 1, and ID sets for the current ID, add letter 2. Otherwise, if letter 1 isn't associated with something and letter 2 is, then letter ID of letter 1 is the letter ID of letter 2, and then ID sets of whatever, let's say, I'll just say current ID is actually letter 2 ID. And then letter ID of letter 1 is equal to that current ID. And ID sets of current ID add letter 1. Else if letter ID of letter 2 is -1, current ID is equal to letter ID of letter 1. Letter ID of letter 2 is equal to current ID. ID sets of current ID and letter 2. Okay, so those are fairly straightforward. You're adding another letter into the stuff inside the sets. You also need to track the smallest element in the set, but before I do that, let me consider how I would have it if both letters are already associated with different IDs. So they're already kind of, for instance, right, if let's say DEO and L are two sets, and there was another equivalence where E is associated with R, then I would need to combine the sets these things contain into one deal. So what's the best, or what ideally is the best, or how should I do that, right? How should I merge sets? I don't think there's an easy way of doing this. I think it pretty much boils down to, because you need to have one mega set, so you need to update update everything in the smaller set to become part of the bigger set, maybe. else need to merge sets associated with each letter currently. So I'll say here if the ID sets, well, so ID1 is the letter ID associated with letter 1, and ID2 is the ID associated with letter 2. I'll see which one's smaller, which of those two sets is smaller. If the length of letter 1 ID, the length of the ID sets of ID1 is smaller than the length of the ID sets ID2. Then I'm going to have a smaller and a larger set ID. I'll say small ID is equal to ID1 and big ID is ID2. Else small ID is, small ID and big ID are going to be ID2, ID1. So now I can go through all the elements of the smaller ID and add it to the bigger ID. So for every element in the ID sets for the small ID, ID sets of the big ID, add the small ID and the letter ID associated with this element is now going to be the big ID. I think that is correct. I think that's correct. And now there's one last thing, and that's keeping track of the smallest element from each ID set. Smallest or min element is going to be min element is going to be initially, it's going to be an array. Yeah, the min element should be an array. It's going to be associated to ID counts. So for each ID, track smallest element of that. For each set ID, smallest element of that set. So initially when you have two letters that are unassociated with some set of equivalent letters, I'm going to create the set, and then I should add min element, append the smaller of these two values. So letter 1, if letter 1 is smaller than letter 2, else let 2. And then if 1 is always associated with the set, then I would update it if this new element that I'm adding is smaller than the previous element. So if the current letter that's new, which is letter 1, is smaller than the previous element in there, so min element of the ID here, which is current ID, then min element of the current ID is this new letter that I'm adding. Same deal here. If letter 2 is more than the min element of the current ID, the min element of current ID is going to be letter 2. And now, when you do a merge, then you should take the min element of both small ID set and big ID set. So the min element of the big ID now is equal to the minimum of the min element of the small ID and the min element of big ID. Okay, so after all this is done, each letter I look up the ID, the set ID, and then the set ID I look up the min element of that set. So for each, let me convert the base string to be the integer equivalent for each character. So it would be ordinal of k minus ordinal of a. Actually, let me say offset is ordinal of a. So minus offset. K in base string. And then for each element in base string, the answer is going to be answer dot append, converting the element to an ID. Actually, let's go ahead and call this letter. So min equivalent is going to be the min element or the ID that you use, which will be the letter ID for this letter. And then answer append. So this is going to be a number. I want to make this into a string. So I think it's going to be char. Is it Python char? Char 65 takes an integer, returns the character. Answer that append char of min equivalent plus the offset. And then I can do return the join of the answer to a string, I think is the syntax there. Min equivalent plus offset. Did I misspell equivalent? Yep. Answer join to a join to a was it like this? The other way around, string answer. Oh my god, I can't remember. Join. Is it Python join list of characters to string? No, it's literally just join. Okay, set change size during iteration. For each smallest element in the small ID, for each element in the small ID, That's odd. Like I'm only adding to the big ID unless the big ID and the small ID are the same ID. I guess it's possible that they're already in the same ID. I guess I can say here, else if the letter ID for letter 1 doesn't equal the letter ID for letter 2. Guess that was a possibility I didn't quite consider. Okay, so correct on the first two, not correct on this. So D, now source code U should be associated with nothing, I see. Yeah, so if it never actually has, if the letter in the base string is never actually shown in the one of the two S1 or S2, then it should be associated with -1 as the -1 is the letter ID. In which case it should use itself as the thing. So I say if the letter ID of this letter is not equal to -1, then do this. Otherwise, you want to just append the letter itself. Answer.append. Actually, I can probably do this better. The min equivalent is going to be that. Else, the min equivalent is going to be just the letter itself. Oh, whoops, this should not be tabbed. Okay. Wrong answer. That's a lot of stuff. Okay, but so the base string has I here, and I think maybe I need to track this somehow. I think this is, let's see, can I think of where the logic might be wrong about this? So you have two IDs. Only time that you need to create a new ID would be if both letters haven't already had a set. So you need to create a new set of both letters. Otherwise, if one of them already has a set of equivalent letters, then just append it, right? So append the smaller if, and then update the smaller, and then update the smaller ID. Seems okay. So alright, so let's see where this thing might fail. So the output here is C, but it should have been A, because C is eventually associated with A in some fashion. So why would it not do that? So let's go ahead and say print out it's not going to look very nice if I just print a bunch of numbers that are equivalent. It's going to be hard for me to associate, or hard for me to debug that. C is supposed to be associated with A. No, yeah. I became C, but it should have been I becomes A. And then same deal here, I becomes associated with C, but it should have been A. Huh. R. I wonder why this is an error. CRC versus ARA. Because the R is correct. And if the R is correct, then it should not really have both the R, have that R be highlighted as red, I think. There's a bug in their differentiating output versus expected deal. But mainly it looks like C is not associated with A correctly. Why would that be? The letter ID, add all things in the small ID to the big ID. Change all the elements in the small ID. Actually, did you? I think you did, right? So, adding stuff to the small ID. Changing the association of D to the letter. And then you're adding. Yeah, I think that's all you need to do to merge. Okay, let's go ahead and actually. Let's see what the raw code says. Print out my, let's say, loop and index. Print out the letter IDs. Or do I want to print the I'll print out the mins, the min element of each, and I'll print out the letter ID sets. This is going to be too much, I have a feeling. This wrong answer was test case 95, okay, out of 116. Okay, so first loop, C is going to be 2, and set 0 is going to be C and G, which is 2 and 6. Next one, E is associated with A, so that's 0, 4, that's set 1. Next loop, I associated with F. So that's 8, 5, set 2. Next loop, F associated with F. Oh boy. F associated with F is not something I would care to actually create a set for. So I can say if they're the same letter, then I just skip it. If letter 1 equals letter 2, continue. Do not change anything for identical letters. Like A equals A, whatever. Okay, so at least it doesn't do that weird thing anymore. So loop 3, that should have been loop 3 now. Oh no, loop 3 was H compared with B. H compared with B was 1, 7. Skip 5. or skip loop 4, where loop 4 was actually FF. And then G and C combine. So loop 5, C and G combine. Oh. That's not what I expected. Oh, C and G have already been merged. So did it actually do anything? So if they're already associated with the same set, then I shouldn't do anything else. So if they're both unsetted, or if they're both one-setted, I think here I need, else if they're both the same set, then I ignore it here. So letter ID of letter 1 equals letter ID of letter 2. Continue. Otherwise, I need to merge it. I guess if they're not this, well, I guess this is already checking that they're not the same set, right? Oh yeah, I guess that follows fine. So loop 5, this was where, actually maybe I can print out the loop and what letters they are. Let 1 and let 2. Maybe I should print out the character equivalent of that. Char of letter 1 plus offset. Char of letter 2 plus offset. Okay. So CG, GC, that's going to be not doing anything. And then loop 6 was E to E, and that's not going to do anything. Loop 7, actually maybe I can do this at the start. Maybe I can do it right at the start. Alright, so loop 6 EE pretty much does nothing. Loop 7 CI. Loop 7 CI. This should modify something now. C and C is associated with what? C is associated with set 0. And I associated with set 2. So CI should be merging set 0 and set 2. Doesn't seem to do that. Interesting. So let's try here. Let's try here, attempting merge. ID1, ID2. So CI, okay, it's merging 0 and 2. But then it doesn't seem like it's actually... Doesn't seem like it actually did it correctly. So if the length of it, so the lengths are the same, so it should say that the small ID is going to be maybe ID2. because length of the first one is going to be 2, the length of the second one is going to be 2. Okay. Let's say small id is small id, big, and then big id. Okay, small d is 2, big is 0. So for every element in the set, so it should be going from 2 to 6. And then id sets, oh, it's adding the small id, it should be adding the freaking element. Oh my god. I'm so stupid. Oh my god. All that for a logic error of the stupidest magnitude. Huh. So stupid. Okay, well, we got there. Not the prettiest code, but it's pretty darn fast, comparatively, I guess. Is there a way for me to combine some of these if statements? Can you add more than one thing? Actually, can you do something where you say a b is equal to 1, print a b? Can you do that? Okay, yeah, you can't do that. It has to be, I have to assign 2 things for that. So I could maybe make 2 statements here, or I can combine this into 1 statement. Actually, Python add multiple elements to a set. Update. Update method modifies set while the union operator creates a new set. Huh. Append multiple elements to a set. To update, you have to have a list of these elements. Alright, I'm gonna give up. Alright, so this thing seems fine. Maybe you can just use ID count so often. It makes sense to say current ID. Okay. And then this one, I wonder if somehow you can factor this to something. Can you make this into a single else if statement, like else if letter ID of letter 1 equals -1, or letter ID of letter 2 equals -1. So you have a single or, and the current ID would be, what would the current ID be? Like, it could be -1, it could be letter ID of letter 1 times letter ID of letter 2 times -1. And that operation would multiply the IDs, and that should come out with the correct ID, because -1 times -1 times the ID. And then how would you know which ones to modify? You modify both letter ID of letter 1 and letter 2 to be that current ID. You add again to both, and you do the minimum of 3 values, letter 1, letter 2, and the current ID. You could, I don't think it's actually any better. It would be less, it'd be less code, it wouldn't be any faster. So like here's what I'm visualizing as like smaller code, smaller, not faster. Smaller, not faster code would be like also letter ID of letter 1, -1, or letter ID of letter 2 is equal to -1, and the current ID is equal to -1 times letter ID of letter 1 times letter ID of letter 2. Letter ID of letter 1 equals current ID. Letter ID of letter 2 is current ID. ID sets of current ID add letter 1. ID sets of current ID add letter 2. And min element of current ID is equal to the min of letter 1, letter 2, and the current minimum of those sets. Min element of current ID. So you could do something like this to condense these two branches into one branch, kind of. But this is not faster, because this is going to take, I mean, the operation here is the same. There's going to be 2 assignments versus 1 assignment. There's going to be 2 adds versus 1 add. And the minimum comparison is going to be between 3 elements versus just 2 elements. So even though there's more code here, it's just faster to do it, to express it out. But funny to think about. And then letter ID of letter 1 equals that. Merge the 2 sets. Get the IDs for the sets. Merge the smaller, figure out what the smaller set ID is. Smaller as in having the smaller number of elements. And then go through the elements of the smaller set. Add to elements, add to the big set. Change the linkage between the element and the ID number, and then change the minimum. Do I have to do this for every element? Yeah, every element. I think I only have to do this once, actually. This shouldn't need to occur more than once. So yeah, minimum can be assigned once. I think that's correct. Alright, this indentation is off now. Is that better? Probably not. Okay, well, just gonna remove it. I don't think, can I do white space like this? Oh, I guess I can. Good. Okay. So for the summary, somehow it slowed down. I think it's just random. I mean, this better be fucking random. There's no way that this thing actually whatever. I'm gonna say that was the 0 millisecond one. So the summary here is going to be for as each letter has an associated set of equivalent letters, maintain that set. The main issue is how to maintain and update those equivalent sets when more info is like pairs of equivalent letters are seen in S1 and S2. So again, the general steps here, and this is the first one was an optional step, which is convert letters to integers such that you can use the ints as indexing for indexing. Otherwise, use dictionary with letters as keys, as character letters as keys. So I have a bunch of arrays here, right? The arrays are indexed by 0 through whatever, 0 through 25, where 0 is A, 1 is B, and so on and so forth. So you just need to do this kind of mapping between the ordinal value of the character versus using the character itself. And if I didn't do that, then I'd have, instead of like sets that are indexed by the ordinal value, I have dictionaries that I just use the letters as keys. It's all the same, really. From there, have a few ways of tracking sets, tracking the association of letters and sets. So one is letter to letter, which is like the ordinal value, to the set ID, and these are unique for each set. And then these are integer, which are unique for each set. And then have the set ID map to set of letters. So this is going to be a default dictionary of sets. Sorry, was the default dictionary sets? Yeah, there was. I could have maybe used an array. Yeah, maybe an array would have been better. And then appended onto the array another set when I need to add it. Yeah, that probably would have been better. So could have been like this, and then when I create new sets, I would say when I create new sets, ID sets dot append another set. I think that's the only difference, because the indexing is going to be still the same. Okay, yes. Set a value. So this can be an array of sets. And then associate a set ID to the min element letter of that set. So those three things, this the ID sets, the letter ID, or the first thing was the letter ID, second thing was ID sets, and third thing was the min element. This last one was just an array. This is like an integer array. The ID is the index, and then the letter is going to be the value in the array. And then process the two equivalent strings, S1, S2, and the primary things to do would be, one, create new sets for two letters that are unassociated with any sets of equivalent letters. Merge, or actually update a previous set if other letter is unassociated. And then lastly, merge two previous sets if both letters are associated to different sets. And you just need to take into account all these interactions when you do that. And also the merger. Merger is like determine the smaller set and move their elements into other set. So again, this is kind of a bunch of housekeeping tasks. So if you do the update, then you have to look at the ID of the set that is associated, add the other letter to that set, change the minimum if the letter is smaller than the minimum of that set. Vice versa for the other side, where letter 1 is unassociated versus letter 2 is unassociated. And then for the merger, you need to, well, you don't need to, but it's probably slightly faster if you looked at figuring out which one is the smaller set size, and move the elements from the smaller set to the bigger one, modify the ID associated with the each element, and then one last thing is to just change the minimum of the sets to be the minimum of either set. So let's change that association. And then finally, this is kind of because I did the optional way of converting characters to letters. Convert the base string to determine the lex smallest string for base string by converting each letter to the min letter associated with the set that it is in, or itself if not associated to a set. So that was this last thing here. If there's no ID that was a new set created for this element, then just put the element itself. Otherwise, actually, if there is an ID associated with it, then get the ID and then find the minimum element of that ID. Otherwise, use the letter. Alright, anyways, time complexity, this can be O of, I want to say this is kind of like O of n, where n is the length of the string. But there's a number of mergers that you can have. I want to say the number of mergers could actually be pretty bad in the worst case, but because the numbers are so small, like there's 26 things, it might be 26 mergers kind of, because eventually if you have 26 mergers, then everything's inside one big set. So up to 26 mergers. Oh. And then space complexity, this can be O of n. No. This is the size of the string doesn't really determine how much space. I think it might just be, actually, you do need to have S1, S2 be created. So yeah, O of n. For the integer equivalent.